Uh, good evening, all of you. Welcome to Unacademy platform. Let's crack it. In this session today, we are going to discuss about the vector calculus part 4. And the previous 3 sessions we have completed vector calculus in part 3. In the first 3 parts, so we have completed a few topics, right? And today we are going to start the divergence as well as curl of the vector today. For the GATE Engineering Mathematics Calculus chapter, Vector Calculus. Use the code Moorthy536 to avail the maximum offer in the Unacademy platform. Yes. Divergence of the. So what is meant by divergence of the vector point function? If f vector of x comma y comma z be a vector point function continuously differentiable in the region R of space, then the divergence f vector is called is defined by divergence of f or del dot f. Divergence of the vector it will be denoted by with the 2 methods. Yes, Tanjal, good evening. Yes, good evening. F vector, here it's what will be the f vector? Here f vector, it's a vector point function. So while applying the divergence to the vector, it is called as del function. Del function to the vector, it is called as divergence. So there are 2 categories available. While applying the delta function with dot product, it's divergent. It's called as divergence of the vector field. While applying the same delta with cross product, it is called as curl of the vector. Curl of vector. So these 2 things important one repeatedly coming topic in the GATE and ESE. Now coming to the f vector. Yes, f vector of x comma y comma be a vector point function, and the divergence of the vector is called as DAV f vector or del dot f vector. We are going to take it as it's a del dot f vector. It's equal to I vector into dou f vector divided by dou x plus, actually in the scalar field what we have completed. So here del pi means I vector into dou pi divided by dou x. It's a scalar, right? It's scalar. While applying the scalar, it is called as the gradient plus j vector into dou pi divided by dou y plus k vector into dou pi divided by dou z. Which belongs to the scalar point function. The same, we are applying the same kind of equation with the dot product with the vector point function. While applying with the vector function, f vector del dot f vector is equal to I vector into dou f vector divided by dou x plus j vector into dou f vector divided by dou y. Then it's a vector symbol here, so we need to use the vector symbol. Here it's dou f vector divided by dou y, dou f vector divided by dou z. In case if f vector is equal to f1 I vector plus f2 j vector plus f3 k vector, then del dot f vector is equal to, while multiplying the f1 what will happen? So in case instead of f vector we are substituting here. So while substituting this value, what we will get here? For this condition. So before completing this process, one shortcut I am giving you. Now del dot f vector, if f vector is equal to f1 I vector plus f2 j vector plus f3 k vector, means it's equal to I vector into dou divided by dou x of first term I am giving f1 I vector plus f2 j vector plus f3 k vector, right? It's an f3 k vector. Now the I vector dot I vector. So I vector dot I vector is equal to 1. I vector dot j vector is equal to 0. K vector is equal to 0. So while multiplying I vector into I vector, it's equal to 1. This I vector into I vector, it's equal to 1. It's equal to 1. 1 into dou f1 divided by dou x. Dou f2 and f3 0, right? Actually, I vector into j vector. First multiply I vector into I vector 1. So dou f1 divided by dou x. Again I vector into j vector, it's 0. So we can't getting the solution, right? We can't get solution for this point. So it's dou f1 divided by dou x. While multiplying the same whole f vector with this j vector, only the j vector term and j vector term it will be multiplied. J vector dot j vector is equal to 1. Therefore dou f2 divided by dou y. Is it clear now? So how we are getting only the f1 in the first term? Only the I vector dot I vector is equal to 1 and other vectors it's 0. Oh, fine. Fine. Look at this condition. Third one, same. Dou f vector, while substituting the f vector here, k vector dot k vector is equal to only f3. So it's a final. And the divergent formula, then whenever they are giving the f vector, I vector coefficient is equal to f1, j vector coefficient is equal to f2, and k vector coefficient is equal to f3. So del dot f vector, that is divergence of the given vector, is equal to dou f1 divided by dou x plus dou f2 divided by z. If f vector is a constant vector, in case given f vector is a constant vector, then del dot f vector is equal to 0, and conversely if del dot f vector is equal to 0, then f vector is a constant vector. Is it clear now? Then f vector is a constant vector. Now the note, from the definition of itself, it's clear that divergence of the vector field is a scalar point function. Is it clear? So while applying the divergence to the vector function, finally we are getting the scalar. There is no I vector, j vector, k vector. So without I vector, j vector, k vector, it's a scalar function, not the vector function. Right? So finally, but in the gradient of the function we have identified that gradient of the scalar point, finally we are getting the vector point. But divergence of the vector, finally we are getting the scalar point function. It's clearly, it's states that definition, divergence of the vector field is a scalar point function. Then one more thing we need to remember, del dot f vector not equal to the f vector dot delta. Both are different, right? So because f dot delta, f vector dot delta is equal to f1 into dou divided by dou x plus f2 into dou divided by dou y. So we are not multiplying any function here. So it's a scalar operator. Okay. Now physical interpretation of the divergence. So what it indicates? Physical interpretation of the divergence applied to a vector field is that it gives the approximately the loss of the physical quantity. For example, the mechanical field, and if you take the loss of the physical quantity, the flow through pipes, right? The fluid mechanics, the losses in the flow through pipes, it's based on the vector field function. As well as the electrical moment, the magnetic field intensity or magnetic field loss, it's based on the vector field function. Right? Then solenoid vector, whenever the divergence of the vector is equal to 0, whenever yes, wrote it, I wrote it, whenever the divergence of the vector field is equal to 0, everywhere in the region R, then f vector is called as, given vector is called as solenoid vector. It's called as solenoid point wave function or solenoid vector. Is it clear now? Whenever no, then the vector is called as solenoid field vector. If the divergence of the vector is not equal to 0, then it is not a solenoid function. Right? Now we are moving to the curl of the vector. Curl of the vector point function. The one more very important point. So students, in case you are having any doubt while I am explaining the concept, immediately ping your doubt in the chat box. Okay, I will be the instant reply here. I will clarify your doubts in the live session itself. So I am handling complete engineering mathematics in the Unacademy Plus course. It's common for all the branches. And if you take the Plus subscription, you can secure 100% math and engineering mathematics in the GATE 22 as well as GATE 2022 and 2023. Right? Okay, look at this condition. And curl of the vector point function. So coming to the curl of the vector point function, and if you apply, so already we have discussed what is curl and divergence, and while applying the dot product, del dot f vector is divergence. It's the same. Applying the del operator to the f, it's delta is called as del operator. While applying the del operator to the vector function f with dot product is called as divergence. With cross product is called as curl of the vector. Now we are going to discuss curl of the vector. So what is curl of the vector? So it's cross product. Curl f vector is equal to del cross f vector. Del cross f vector. So while multiplying it, the same. I vector cross dou f vector divided by dou x plus j vector cross dou f vector divided by dou y. Then k vector cross dou f vector divided by dou z. If f vector is equal to f1 I vector plus f2 j vector plus f3 k vector. Is it okay now? F vector is equal to f1 I vector plus f2 j vector plus f3 k vector. Del cross f vector is equal to, now the cross product. Now the del and as well as here f vector we are multiplying cross product, right? So on example I will give you. In case if I am giving two vectors, for example, listen. So based on this formula, I will give you. Now I am going to give you the some vector p vector. Now take it as p vector, which is equal to a1 I vector plus b1 j vector, for example, c1 k vector, right? Likewise, q vector is equal to, now the q vector is equal to a2 I vector plus b2 j vector plus c3 k vector. And if you multiply the two vectors with cross product, and how to write the cross product? And first we need to write the common term, I vector, j vector, k vector. First vector, which vector is the first vector? P. From the p vector, I vector coefficient below the a1, j vector coefficient b1, k vector coefficient c1. The second vector, q vector, next one. For the next one, I vector coefficient a2, j vector coefficient, and followed by the k vector coefficient. Is it clear now? So this is what we are applying here. P vector cross q vector, a1 I vector plus b1 j vector plus c1 k vector. Right. The same here. What we are doing here, multiplying the del cross f vector. We are multiplying the del cross f vector. Now it's I vector. It's I vector. Then the f vector. So while multiplying here I vector. So only the del. Del we are aware of it. Del is equal to, del operator is equal to I vector into dou divided by dou x plus j vector into dou divided by dou y plus k vector into dou divided by dou z. So this is the del vector, right? Del operator. So f vector, here the f vector, here multiplying f, right? It's equal to f1 I vector, f2 j vector plus f3 k vector. It's very important one. Listen. So as per this methodology, we are applying I vector, k vector, j vector. Now the coefficient of the I vector, j vector, k vector. I vector coefficient is equal to dou divided by dou x. Then j vector coefficient, the del operator, it's equal to dou divided by dou y. K vector coefficient dou divided by dou z. Now the k f vector, I vector coefficient is equal to f1 vector, j vector coefficient f2 vector, and k vector coefficient f3 vector. So this is the curl of the vector. In case they are asking divergence, what we need to do? Dou f1 divided by dou x plus dou f2 divided by dou y plus dou f3 divided by dou z. But here, coming to the curl of the vector. Hi Ashish Sharma. Welcome to the session. Now, curl of the vector, del cross f vector is equal to, it's determinant of I vector, j vector, k vector, and coefficient of I vector, j vector, k vector, the first one. Second f vector coefficient f1, f2, f3, right? So this is what we are applying here. This is clear? And in case if f vector is a constant vector, if f vector is a constant vector, then curl vector curl F vector is equal to 0 vector. Curl of the vector, curl F vector is equal to, it's a 0 vector. Is it clear now? Okay, nice. I will explain it. Listen. Now, curl of the vector, irrotational vector. So, what is going to be irrotational vector? Whenever the curl of the vector is equal to 0 vector, 0 vector means 0 vector is equal to 0 I vector, 0 k vector plus 0 vector. Maybe 0 or it is denoted as 0 vector, right? Whenever the curl of the vector is equal to 0, then the given vector is called as, F vector is called as irrotational field vector. Rotational vector field, right? And coming to the conservative vector field. Conservative vector field. So what is mean by the conservative vector field? A vector field F vector is said to be a conservative if there exists scalar function pi such that F vector is equal to del pi. So by applying the scalar point function, yes, in case we are getting the point function, scalar point function, in case by applying the gradient, that means by applying the del operator to the scalar function, in case we are getting the F vector, then that particular vector is called as conservative vector, right? So whenever we are applying the, it's a scalar, whenever we are applying the del operator to the scalar, then we are getting the vector function, vector point function, vector function we are getting, right? So this is what we have discussed in the previous video. So whenever the del pi is equal to F vector, the given vector, when it will be derived with the given scalar, then the vector field is conservative vector field. Whenever the given vector field is when it is called as conservative, when it is equal to the del pi. So whenever the vector field is conservative and del cross F vector, that is curl of the vector, del cross del pi is equal to 0. Always del cross del pi is equal to 0. So we need to remember this point, right? So this scalar function pi is called the scalar potential of pi. So here from these 2 points we can conclude whenever the divergence is equal to 0. So what point we can conclude? Solenoid here. Here we can conclude the 2 points. One is if divergence of the vector field function, that is del dot F vector is equal to 0, then F vector is called as solenoidal vector. Solenoidal vector. So we are going to discuss the previous questions with this topic. Now, whenever the curl of the vector, curl of the F vector, that is del cross, curl means cross product. Is it okay? Is it clear? Oh, del cross F vector is equal to 0 vector, then it is called as irrotational vector. It's called as irrotational vector. Is it okay now? Okay, fine. Now, based on these 2 conditions, now we are going to discuss few previous questions. First question, the vector field I vector and j vector are the unique vectors. I and j vectors are the unique vectors. Whether it's a divergence free vector, there are 4 options are there, right? So we need to check. So what kind of equation? Divergence free but irrotational. Irrotational but not divergence free. Divergence free and irrotational. either divergence free or not irrotational. So these things we are going to discuss. Right? Is it clear now? Okay, listen. Yes, sir. The first one, the given vector, we need to compare this vector. F vector they are giving, right? F vector they are giving. So this F vector is equal to F1 I vector plus F2 J vector plus F3 K vector. F3 K vector, right? It is equal to Xi vector minus Yj vector. And if you compare the equation, then what we are getting here? What will be the formula? Yes, F1 is equal to X and F2 is equal to minus Y. F3 is equal to 0. F3 is equal to 0. So this is what we are concluding, right? Now, so the curl of first one, divergence of the vector point function we need to apply. The divergence we need to apply. Whether it's equal to 0 or not equal to 0. Now, divergence of the vector F vector is equal to del dot F vector is equal to dou F1 divided by dou X plus dou F2 divided by dou Y plus dou F3 divided by dou Z, right? Is it clear now? Is it okay? Okay, fine. Now substitute the value. Now dou divided by dou X of X plus dou divided by dou Y of minus Y plus dou divided by dou Z of 0, and if you apply it, it's equal to 1 minus 1 plus 0. It's totally is equal to 0. Whenever the divergence of the F vector is equal to 0, then it is called as solenoidal vector, right? It is called as solenoidal vector. It is divergence free, right? Okay. Next one we need to identify. That next statement, what we need to identify? Curl of the vector we need to identify. So here we are doing the curl of the vector. Now, curl of the vector. So what about the curl of the vector? It's del cross F vector. Del cross F vector is equal to I vector, J vector, K vector, dou divided by dou X, dou divided by dou Y, dou divided by dou Z. F1, F2, F3. F1, F2, F3. And if you substitute it, it's I vector, J vector, it's K vector, right? Okay, fine. I am substituting it. And it's dou divided by dou X, dou divided by dou Y, dou divided by dou Z. Now coming to the F1, X minus Y, 0. Now substitute the modulus here. And if you substitute the modulus, what we are getting here? It's I vector into. We need to substitute dou divided by dou Y of 0 minus dou divided by dou Z of minus 1. It's completely 0. Minus. Is it okay? Now this continuation I am doing here, right? Excuse me. I will do this continuation here with a different color. It's equal to yes, it's continuation I am doing here. Look at this concept. It's equal to I vector into dou divided by dou Y of 0 minus dou divided by dou Y of minus Y minus J vector while taking the determinant. Now dou divided by dou X of 0, right? Minus dou divided by dou Z of X. It's not possible. Plus K vector into now dou divided by dou X. So again we need to do dou divided by dou X of minus Y minus dou divided by dou y of x. It's completely zero. It's completely zero vector. Therefore, it's irrotational. Irrotational vector, right? Is it clear now? So it's divergence free and irrotational. So we have identified the two things, right? It's option C. Divergence free and irrotational. Okay, fine. Now one more question. So the divergence of the vector field function we need to identify. So what will be the divergence of the vector field function here? What will be the divergence of the vector field? Yes. Now I am going to give you again compare this question. Compare the divergence vector. Its f vector is equal to f1 I vector plus f2 j vector. It's a formula, right? It's f3 k vector. Now compare this. It's equal to x minus y into I vector plus y minus x into j vector plus x plus y plus z into k vector. Now what about the value of f1, f2, f3? Now f1 is equal to x minus y, f2 is equal to y minus x, f3 is equal to x plus y plus z, right? Now we need to do the divergence. So now coming to the divergence of the f vector, it is equal to del dot f vector, right? It's equal to dou f1 divided by dou x plus dou f2 divided by dou y plus dou f3 divided by. Is it clear now? Yes or no? Dou f3 divided by dou z. Now substitute the value. It's dou divided by dou x of x minus y plus dou divided by dou y of y minus x plus dou divided by dou z of x plus y plus z. And if you substitute this value, divergence of f vector is equal to, with respect to x, 1, with respect to y, 1. Now with respect to z, again it's equal to 1, it's equal to 1, it's equal to 3. Now 3 is the divergence. Now the divergence of the vector field is equal to 3. Is it clear? Okay, fine. Now we are moving to the next question. Guys, in the previous 3 videos, vector calculus part 1, part 2, part 3 available. There you can get the complete clarification on the first half of the vector field. Okay, next one. And divergence of the vector field. Here also the same divergence and the same as like the previous question, right? So here 3x I vector. First, what we need to do? The divergence at that point. So while applying the vector field function, divergence I am going to give you. First f1. f1 is equal to 3xz. What about the f2? What about the f2? f2 is equal to 2xy. Then what about the f3? f3 is equal to minus y z square. Now the divergence of the vector field, it's equal to del dot f vector. Del dot f vector is equal to dou divided by dou x of 3xz plus dou divided by dou y of 2xy. With respect to x, it's a 3z. With respect to y, plus 2y. With respect to z, minus 2yz. Now substitute the divergence. It's a divergence of the vector f. Now we need to substitute divergence of. Listen, I will explain. Divergence of f vector 1, 1, right? It's 1, 1. If you substitute 3 into 1, z is equal to 1 plus 2 into 1 minus 2 into 1 into 1. It's equal to 3 plus 2 minus 2. Again it's equal to 3. For this question also the divergence of the vector field function is equal to option 3. Option C, answer is equal to 3. Yes, very good sir, it's 3. And we are moving to the next question. Here, which of the following describes the relationship among the three vectors? First one, it's linearly dependent or linearly independent or mutually perpendicular or unit vector. It's not a unit vector, right? The values are changing, so it's not a unit vector here. These vectors are not a unit vector. Is it clear now? These vectors are not in unique vectors. The vectors are mutually perpendicular. The vectors are mutually perpendicular means if you multiply the two vectors with dot product, it must be 0. Now check either the first and second vector is equal to mutually perpendicular vectors or not. Plus 3j vector plus k vector, and if you multiply I vector and I vector 1, it's 2. J vector and j vector coefficient 3, k vector and k vector coefficient is equal to 1. It's equal to 6, not equal to 0. Here it's not a mutually perpendicular. Now we need to check whether these vectors are linearly dependent or linearly independent. Two things we need to conclude. So how to identify the linearly dependent or independent vectors? How to identify it? Whether it's a dependent or independent? Yes. And if you take the modulus for all the coefficients, if it is 0, linearly dependent, or it's not a linearly dependent one. 1, 1, 1, 2, 3, 1, 5, 6, 4. Right? It's a determinant we need to do. And what about the determinant? And if you identify the determinant, it's equal to 1 into 12 minus 6. Minus 1 into 8 minus 5 plus 1 into 12 minus 15. It's equal to 6 minus 3 minus 3. It's equal to 0. It's equal to 0. So it's equal to 0, therefore linearly dependent. Linearly dependent. If it is not equal to 0, linearly independent. Is it clear now? This is the procedure to identify the given vectors are linearly dependent and are not. If any, yes. Now, while multiplying the first and second vector, it's not equal to 0. So first and second are not mutually perpendicular. If you multiply the second and third also, it's not equal to 0. So second and third are not mutually perpendicular. If you multiply the first and third vector, here also it's not equal to 0. So all the vectors not mutually perpendicular to each other. Okay? Okay, next one. Yes, curl of the vector we need to identify. So what will be the formula for the curl of the vector? It's curl of the vector f vector, it's equal to I vector, j vector, k vector, dot divided by dou x, dot divided by dou y, dot divided by dou z. Now we need to identify f1, f2, f3. Now it's f1, here it's f2, it's f3. Now substitute these things into the question. Now curl of the vector. Curl f vector is equal to I vector, j vector, k vector, dot divided by dou x, dot divided by dou y, dot divided by dou z. What about the value of f1? X square, z square. X square, z square. What about the value of f2? Minus 2x, y square z. Minus 2x, y square z. What about the value of f3? 2y square z cube. 2y square z cube. And if you do the multiplication, now I vector into dot divided by dou y of 2y square z cube minus dot divided by dou z of minus 2x y square into z minus j vector into right dou divided by dou x of 2y square z cube minus dou divided by dou z of x square z square, right, plus k vector. Now plus k vector into dou divided by dou x into minus 2x y square z minus dou divided by dou y into x square z square. Now do the simplification, differentiation and simplification. Then what we are getting? What we are getting here with respect to y? With respect to y, I vector into which 4y z cube minus of minus plus with respect to z plus 2x y square minus j vector into with respect to x first one 0 and second one minus of minus which is plus with respect to z 2 x square z into j vector plus k vector into with respect to x minus 2y square z, second one 0, right? Now what will be the value? 4y z cube plus 2x square y. So here then plus 2x square z plus 2x square z is available in the option A. So option A is the right answer for the curl of the given vector, right? So thank you all of you. In the next session tomorrow we are going to discuss the one more topic from the vector calculus. So try to take the plus subscription to avail the complete course on the engineering mathematics as well as core subjects. Then yes, the benefits I will tell you. Before when closing the session, I will tell you the benefits of the Unacademy platform and what are the tests going on, right? So Unacademy Compact. So we are conducting the Unacademy Compact every Sunday, right? So already Mega Compact over. 4th over, 11th over, next 18. India's largest weekly competition. If you attend the India's largest weekly competition, so you can avail the free subscriptions, right? It's eligible to department mechanical, civil, electrical, electronics and CS. 1 to 3, 1 year Unacademy complimentary subscription. Rank 4 to 10, 75% offer. 11 to 50, 50% offer on the Unacademy Plus subscription. Rank 51 to 100, 25% offer, right? So this is a batch, June 16th batch. Already we have started the mechanical engineering batch. We completely syllabus will be discussed in English. So try to take the plus subscription. Okay. Thank you all of you. Direct to the outer one.